ones did you intend for us to do?
I think it was 436.
46?
Was it 46?
46 was involved.
Yeah, 46. Well, it wasn't too involved. You just had to make one observation that we hadn't made. So I do want to talk about that. And then instead of doing 51, I really wanted you to do 52, I think is what it was. But it doesn't matter. Actually, the one that I had you do was harder than the one I wanted you to do. It just involved more stuff, so it wasn't real big. Okay, so 430. We have a free body diagram. Looks like this. We got this cable going down here. We're going to show it in tension. We'll call that tension in BC. And that's off at 60 degrees off the horizontal axis. And we've got this post, if you will, beam. Then we've got AX. We're going to say it's going to the right. That's probably a good guess because the tension in BC is going to the left, isn't it? So that's probably a pretty good educated guess. AY. Then we've got this beam that comes off here, and it's supporting 1,200 pounds, right? Okay, we got a distance here of 3 feet. And to the top is 5 feet. And then we've got a distance from AY over to that 1,200 pounds of 6 feet. So we'll do sum of the forces in the X. That relative to 0, right? And we've got minus the tension in BC, cosine of 60, plus AX. Two unknowns, we move on. Okay? Sum the forces into Y. AY minus the tension in BC, or excuse me, tension in, the tension in BC, sine of 60, minus 1,200. That's it, right? 1, 2, 3. All right. Still two unknowns. So we'll move on. Now I'm going to move this. Let's see. I'm going to try moving this a little bit here. I might be able to squeeze some more out. Whoops, don't want to do that though. Okay, I guess that's as good as I'm going to get right now. So we'll do a moment. Summation of the moment about point A. Okay, so we got the tension in BC times the cosine of 60 degrees, right? That's the X component. And that's making that thing go counterclockwise, which is positive, right? Okay. The Y component goes right through the point, doesn't it? It would be right here. So it gets dropped out because it doesn't spin. It doesn't have a distance, does it? AX and AY go away, so the only other thing is the 1,200 pounds. It's making it go clockwise, which is negative. Oh, excuse me. I left something out there, didn't I? Got a little bit of a hurry. Don't get in a hurry come test time. What I leave out, Clark knows, but nobody else is telling me. Distance, 8 feet. Okay. This is a moment, so you have to give a force and a distance. Minus 1,200 pounds. Everybody understands why it's 8 feet, right? If you don't, it's 3 plus 5. It's the x component, right? Okay, 1,200 pounds. And it is 6 feet away from A. Okay, so now we can put the 1,200 pounds on the opposite side of the equation. Move that up there where you can see a little better. Excuse me. So we'll have the tension in BC equals, this moves to the other side, it's 1,200 pounds times 6 feet divided by cosine of 60 times 8 feet, right? That's how we solve that. This was multiplied, so when you move to the other side of the equation, it has to be divided, right? That turns out that you got 1,800 pounds tension in the cable BC, if you will. So we do finally know something. Okay, so then we go in there and we substitute the tension in BC for these other equations, and we can calculate what they are. So we can put 1,800 pounds here. Well, let's move that to the other side. We could just say 1,800 pounds cosine of 60 equals AX, doesn't it? Do what? Okay. Oh, okay. Yeah, just ask. What we did was we just, instead of scratching this out and putting the 1,800 there, I just moved it over.
I was looking down here at the bottom.
Oh no, we're up here.
Yeah.
Yep. Solving for AX. So if we do the math on that, AX equals about 900 pounds. So I'm guessing the cosine of 60 is about a half, isn't it? Okay, so 900 pounds to the right. So that's the reaction at A in the x direction. Substitute that in here, 1,800 pounds for the tension in that cable. AY stays where it's at. Everything else goes to the other side of the equation, so these become positive. So 1,800 pounds sine of 60 plus 1,200 pounds should come out to be something like 2758.9 pounds up. What's happening to my screen there? Oh shoot. It is Friday, isn't it? That's a good thing. Okay, so it's wanting to play already, isn't it? That's alright. Can. Clark?
How would we know on a test if you want the reaction of point A to be in as one force as a vector with an angle, or as the components?
Well, like I said, what I'll do on the test is I'll put the problem out there, and then I'll put over to the side.
Oh, okay.
I want AX equals, and there'll be a blank spot, a line. So I'll have those all listed, so there won't be any question. Yeah, that would, because that could be difficult. Okay. So, but normally I like, that's what I'm going for, is the reactions in A and X. Now on one of the other problems, I think it was that 46. It ultimately wants that resultant vector. Okay. And like I said, I sent you an email saying that really wasn't the one I had wanted to do, but I went ahead and did it so that we could go over it, because it is kind of a neat problem. Anything else on this one? So yeah, on the test I'll have it all listed out, what I'm looking for. And if you can do these problems like that one right there, and these other problems we've been working on, you will not have any problem with this test. If you've been doing the homework, you'll buzz right through it and think, why was I sweating it out? It's pretty much what it'll amount to. Okay? And then you'll wonder why anyone else would ever struggle. It's just math, isn't it? It's math that you're applying. So it is kind of, this I think is when it starts to get to be fun, to be honest with you. It's like Brian and I were talking the other day, you're going across that bridge and you're wondering how it got designed. Well, you're going to find out. Because once we start getting into the trusses, that's all a bridge is, isn't it? Is a truss with girders. The girders are going the opposite direction. So will you ever apply that to anything mechanical? Well, will you ever build a machine that has to have a base that has to support all the other functions of that machine tool? Probably. So, or it might be an instrument like we have some companies that do a lot of medical devices. Maybe like a drill or something like that. Well, you have to be able to calculate those forces that tube that holds that whole thing together is going to be able to withstand, and not make it so bulky that it can't get in somebody's mouth to do a drill operation. So yeah, hopefully it's getting to be neat stuff for you. Now 46, it's a little bit more detailed. And what I did over on the left side, I drew I put a number in and drew a circle around it. That was the order of operations on how I solved it. So it's a little, because you have to do a little jumping around on this one. Okay, so the